All right, continuing the Haynes Welding Manual, Chapter 5, Mig Welding. Choosing shield gas. By now you should have known the idea of the level to make the loyal soup with your purpose of the home shop, the wiring. You go into welding every day with the need to be served with a typically entry level 140 amp, 110 volt MIG welder machine shield gas. You now have to choose a shield gas bottle to now include with the MIG machine. Some of the wire sample the roll might include with your machine. The typical type of the shield gas thing you want to use. The sound light of the machine. A lot of choices, but the field is narrowed down by the what kind of the work you want to do, but not how often you need to do it. In all cases, the choice of the shielding gas wire type that must be matched with the kind of material you will welding. Capacity of the gas bottle is important most of the time the welder making possible. Capacity of the gas bottle is important most time the time welders make mistakes buying less capacity because the bottles are cheaper. They're only to find themselves someday working on the project over the weekend when there's little chance of getting the bottle refilled, and they're out of gas. Though a gas bottle is available inside of the 20 cubic feet, 40 and 60 and 80 and 125 cubic feet. This is roughly translating the welding time from the hours to for 20 cubic feet. The bottle is up to 14, 16 hours. The 125 cubic feet was used in a small machine with 140 amp. The unit, for example, the number of factors involved with how long the particular bottle may last under the different welding conditions. So they're roughly guideline. Every time they use the make machine, you might, just look at the tank gauge to see how much more gas you may even have even want to just a little small cylinder gas when you first get the machine, just to see how long the tank would last and how much bigger the one will you if you think you need. All right, the small bottles nicely under the small welding cart make it the very portable arrangement. Occasionally, home use to see the illustration above. See the illustration. This is a gas shield make. They're not made for the outdoor work. Though, as long as they keep the wind with the wind currents and the wave of the work is fine. The driving all the utility trailer project pays for the plywood are used for the wind shields or while welding. Most your welding and shield gas can be done with 75% to 25%, 75% argon, 25% carbon dioxide mixture with excellent cleanliness penetration, which can be used in the cast iron stainless steel as well. The large bottles are heavy and bulkier, so you'll have to build a welding cart most of the time. The welder first project to accommodate one, but of course the body of the compressed gas for the air, even the gap is not flammable due to the presence involved with any of the gas welding bottles must be securely mounted with the chain sturdy. The clamps. It's important to note that welding bottle with electrical welding machine should be ideally mounted in an insulated manner, such as with the rubber underneath the sub-rubber hose over the restraining chain to prevent the remotely possibility arcing against the cylinder, which could damage it. Next, their choice of shielding gas do you the ones for the widely used shielding gas to make it work when it's plain carbon dioxide or CO2. While in this bottle, the carbon dioxide is really an air gas that typically turns to the carbon monoxide oxygen. Under the intense heat of the arc process, the oxygen combined with other elements in the air with the parent metallic metal with the undesirable oxides. This plain CO2 will not usually result in clean as a weld with other gases, but is used because of the less extensive the shield gas for welding steel. It's weld very fast and good penetration, but should be used with welding wire with it contains deoxidizing element counteracting the effect of the pure carbon CO2. Along the versatile in-air shield gas that is often itself with a combination of other gases to produce that can certain welding characteristics. For instance, welding non-ferrous metals and materials, aluminum is usually done with pure argon and makes a good penetration pattern of the concentrated arc. While the ferrous mild steel will be used with the home shop with the project, the argon simply is usually mixed with another gas, and sometimes other gases to provide special characteristics. Well, there are some esoteric mixtures, gases, and different percentages specific purpose of the mixture. 75% argon, 25% CO2 has become pretty much for the same, but the welding metal steel short Art Mig Welding machines wire diameter for 35,000 of inch or less illustrate the mixture of the often improved with the C25 is more expensive than the plain CO2. They produce much less splatter and consistently better looking weld. Even the material as existing minor rust or scale. If what we recommend for most of your welding needs, if we're doing a lot of thicker materials overhead with the other position out of position welding, the pipe welding, you must also have a 50-50 mix of argon, CO2, which offer the good wetting in the bead shape without excessively fluidly causing the bead to drop and fall when doing out of the position welding. If you work on in a body shop, you might be interested in a mixture of the aerial called Argo Shield, which stands in light gauge and consistently mostly argon with a small addition of CO2 and oxygen combination designed melted down 20 gauge to produce a good penetration, smaller welded be normal, less sheet metal finishing, less splatter, smoke, and the good arc starting. The specifically formulated to work well in the thin and low alloy steels now used on auto sheet metal. For welding of a non-ferrous material, either shorter arrangement mixture of the argon and helium that you with the various combinations to provide higher heat into the Mig arc. Usually, the thicker material is welded, the higher the percentage of the helium is included with the mix of the helium-75 gas or 25% argon 75% helium. Typically used in the industry to weld thick aluminum. If you were interested in welding stainless steel, you actually use the C25 gas recommended above the mounted steel with a mixture of 90% helium, 7.5% argon, 2.5% carbon dioxide, which is widely used in stainless steel MIG welding because of the offers higher heat with normally sluggish welded pool and stainless as well with often good stability and penetration, resistance to corrosion. If you have to pick up just one type of gas, the C25 works with grace on steel and can be used with stainless steel. It's also usable on cast iron. Choosing a wire. The bare steel wires are used in bolted shield and bottled shield gassing. The MIG machines are variations, same as basic metal with the various amounts of the deoxide. Is different than the application shield gas. The most common deoxide is silicone. Other options added may be magnesium, aluminum, titanium, zirconium, nickel, chromium, molybdenum, and added to improve the mechanical corrosion or resistant property of the welding wire. With the higher level of the oxide, generally better are able to weld rust on unclean steel surfaces. Most of the steel wires that make welding fall under the designation of the American Welding Society of E70S. Something the last digit particular variation for the instance, one most common the specification of the E70S2 is the oxide makes the good weld C25 gas even in rusty steel. Its main drawback is lack of fluidity, and the puddle does not want to flow out widthwise, may not stick well with heavy materials. The E70S3 wire, one of the most common and less expensive of the MIG wires available to deoxidize with more fluid puddle with the makes up the welder app being bead and has been used successfully on years of car farm equipment and application. Next up, the term of the deoxidizers contains the E70S4, which is medium-priced wire suitable for the all steel welding. It offers a good fluidity, better arc characteristics than E70S3, but has slightly more spatter and use than structural steel and ship than piping the boiler vessels. Probable high-performance, higher cost wires, the E70S6, which has the highest level of silicone magnesium dioxide, suitable for the welding of almost all steel, from middle steel to 1/2 inch and appropriate wire diameter works with the popular gas mixtures offering good puddle fluidity. To see illustration, use the few MIG wires that's completely compatible with today's thin, low alloy, high strength body metal and unibody cars. Inside the wire drum, the typical small MIG machine goes with small wire rolls such as lower right and becomes the adapter that holds the handle to the large rolls and such of the machine. The small wire rolls are inconvenient unless you do lots of only small projects. This is the drive section of the Daytona MIG wire feed, which has placed inside a store inside of the small roll of the wire, good for keeping the spare clean with occasionally switch to another type of the wire with specific needs. Allows the air indicator of the knob to adjust the wire roller tension. The LTEX mark of the wire meeting the AWS grade for the AR70S 2 and 3, 4, and 6. They are called the Easy Grind, which is designated specifically auto body work. It says to require that less skill with the thin materials to reduce the carbon content with the means of the grinding and preparing with the filler of the painting of the butt. Besides automobiles, it is also used for the welding ductile metal capability, lawn furniture designated with the metal of the 26 gauge for small MIG machines. Non-ferrous metals, of course, they require different wire for the basic rule of the welding electrode selection chosen what the wire electrode with the content with much of the same of the parent welding you are welding in the case of the stainless steel. It can be welded with a steel wire. We have recommended above the better corrosion resistant. The main reason for making something of the stainless steel less steel in the first place. Stainless steel wire should be used for the various alloy stainless steel, but one of the more common variants, the type of 304 West wire with the MIG welding with 304 is called the ER308. The variation of the increasing silicone content of the ER308L and the ER308LS. For aluminum welding, you need all the aluminum wire. Again, they are all they many all the variations of aluminum. Several of the metals bend in aluminum wire. Perhaps the most make the wire with aluminum is called the ER5356, which has a chemical content proven to work in the best most situations. Aluminum welding is more difficult than steel in many ways. Often the exact alloy of the parent metal is impossible to determine unless you have brought large enough pieces of metal that you are of the steel factory. So it's always and so it's alloys and heat treatment there, even in some aluminum alloys which are considered unweldable, like high-strength aluminum, such as 7075 T6. 536. Your wire welding supply store have a variety of mixed electro wire tubes from the E70S6 wire at the left, one of the most popular, and at the right, LTEC easy grind body of work. 537. When starting a new roll of wire, keep the pair of pliers at the end of the tack of the reel, end you take of the reel, or the wire can unroll everywhere. Feed the wire through the guide over the driver roller. The wire tension adjust with the knob. Proper tensions avoid the wire twisting problems inside of the gun. The wire should be able to split when it needs, and most machines have features that allow you to retain tension setting the ones you set. By swinging tension arm away, then changing the wires. All right, learning MIG welding. One of the attractions of MIG Welding has brought these machines to the home of the shop of the market that has easy to learn with the little instruction. Virtually any one of the MIG Welding hours practice at the time, as everything else, but they must have the practice. Easier it will be, the better with your welds. But before you are overconfident about your MIG weld, is cutting the part with a seam that you may have to make made to check the penetration, make the other test bending of the two but weld same plate with a vise with a place and a vise. Prove this described and see if the welds you were making as strong as the good-looking ones. To set up the MIG machine, the first step to be read all the direction cards for the instruction book is to come with. Once the few adjustments that you have, then initially do the pull the roll wire through the machine, set up the drive of the roller while the wire unrolls from the reel guide over the motorized roller. The wire feeds through another guide into the cable to going into your torch. Lay your torch and cable out of the floor straight as possible, mounting the wires into the machine as the power per your directions. But be careful that when cutting the end of the wire, which usually bent over the lock into the hole inside of the reel, the winding tension of the wire is cut at the end of the wire and gets away from you. It can start unraveling all over the place, but do not cut the end loose until you are ready to feed it. Hold the cut in some pliers, vice grips carefully, follow the channel, then cut the end of the smooth, sharply cut the end of the snag with it travel through the cable toward the torch. Insert the end of the guide, loosen the swing of the away from the wire, tension the edge adjuster, feed the wire with it over the groove of the driver roller onto the next guide, still holding the wire firmly. Most machines are set on a handle. Supple wires must be, but you must be certain that driver roller groove the right side of the wire you're using. Most rollers have two sides of them that can be turned around and on the shaft to pull the other side of the line in the wire. There will probably be an extra roll with other sides on it that comes with your machine. When the 6 inches or more of wire have been fed into the welding cable, the wire and tension adjust the back into place over the wire, keeping the wire centered into the groove. Turn on the welder, put the wire speed on 1/4 of the way. Pull the trigger at this point, adjust the pressure of the wire, tension there, and unit of the rollers, and then feeding the wire, and then turn the 1/4 turn more. With the nozzle contact unscrew with the end of the torch, keep the torch cable straight with the run of the wire much until the wire comes out the torch. Slip the correct side of the contact tube over the wire, screw it in, and attach the nozzle. Final check of the wire tension, making sure that the wire can slip if necessary. Eventually, the big practice, you will virtually weld the wire to the contact. And when this happens, you are still pulling the trigger. You are still pulling the trigger. The machine material feeds it, but it cannot come out of the gun. So it's jammed inside, and it's called a bird's nest. Prevent this bending of the wire to side of your torch. Put this nozzle right against the shop floor, simulating the struck wire. Simulating the struck wire while watching the drive mechanism inside the mechanism. Pull the trigger and drive the rollers through. Drive the rollers should have enough tension to allow the pull the wire through, but not enough to prevent slippage in the case of the jam. If your rollers do not slip in this test, you're set. If your flux cord wire machine, you are ready to weld, but for the shield gas machines, you have to set up the bottle with the bottle mounted with the firmly on the cart. Attach the regulator of the bottle. Attach the reinforced hose. Should come with your machine, the regulator with the hose clamp with the connection of the rod with the gas machine. On some of the machines, a special adapter clamp with the reinforced hose with the small plastic hose going to the machine, and keep the two regulators engaged with corrective impact. Always keep the gas valve turned off when you are not using the machine. Some of the cylinder valves on sealed when the valve is either fully on, fully off, or fully on. So your machine then turn the cylinder all the way, and not just a few turns. You can check on any of your gas connections leaking using soapy water solutions. Bubbles indicate leaks. Adjusting your gas to proper flow cubic feet per hour according to your instruction on the material of the wire you are working on. Note that one gauge tells you the flow rate, other tells you how much pressure is still in the bottle. You can read either only with unless the cylinder valve is turned up on. So do not look at your bottle one day. Do not look at your bottle one day and notice the 10 gauge looks empty. Turn the valve to really see what's left. All right, 539. So these are three choices for the regulators to make shield gas. The up unit at the right is a single gauge economy unit, which indicates only a line flow. Note the total tank pressure to the left in the dual gauge unit is shown for both, and center is more in the center is more professional mode with floating ball float meter, easy to read from distance. Now you're ready to practice. Some select 1/8 inch steel, some of the amperage according with suggestion of your instructions. Set your wire speed a little higher than what's recommended. The wire speed and the key to getting over the good proper heated penetration. Tuning the speed easily and listening to the sound of the welder making it was straight ahead. But the speed is too fast, and most of the wiring coming out will be red hot. There was a loud crackling noise. Gradually adjusting the speed down until you get a steady sizzling sound. The wire should be smelting right at the weld. Practice turning the wire speed to different power settings and metal thicknesses. Alright, 540 for the basic mega units have only a few power settings. Your instruction sheet will tell you the recommended thickness for the metal each for the set. Hitting jar on the front with the machine usually tell with the amperage of the duty cycle for the setting. There's some of the practice with the different material that you will instinctively which settings work best for your work. 541. Wire speed, it has a lot to do with the heat of the quality of the weld. Generally, when you have the right, the machine makes a satisfying, steady sizzle sound. Practicing adjusting higher and gradually lowering it until the sound results in satisfactory. If you do the repetitive work, write down the amperage and wire speed settings that you have worked for. Alright, and also 542, on one of the two methods of gun travel to make welding before beginners often use the reverse or backhand method because they can watch the puddle acting much better. The reverse angle welding direction, reverse method, okay? And the forward method of welding direction. There are two holding machine techniques to make welding for him. The back end, the first of when the torch is angled to move so that the weld is to take place ahead of the torch direction travel. The backhand is weld to take place behind the torch. Most of the beginner find the backhand, also called dragging the weld, technique that works best in most of the steel welding projects, giving the welder a better view of the puddling action in either style. The torch is angled with 35-degree degrees of the work. If you find yourself with a vertical seam, that you can travel either up and down by using the hand force or forehand technique, sometimes called pushing the weld. Only when you're going up the backhand technique, going down, keeping the arc on the puddle's leading edge for the times of good penetration. After making good straight bead for the top plate, try joining two plates, and if you're working with the metals under the 1/8 of an inch, most of the steel can be made the welds of the bevel edges. One should tackle the parts together with a slight gap between them before finishing the seam with a full weld. The assure of the good penetration 1/8 of an inch thicker metal's edge should be beveled before tacking them. If you find constantly burning through the material and heat seating is too high, that you remove it slowly. If it is cold and appearing with non-penetration, the amperage of the bead too low, you may be traveling too fast. You're adjusting treble speed with the torch, watching how huge a puddle will develop, moving the torch along in slow, steady rate. One of these great advantages of the make process is that the torch is right down close to your work. There's much intense light, and then the heat spatter from the arc weld, and you can get closer to the work really to see the puddle progress. Keep a pair of sharp wire cutter pliers on the welder at all times. When you start each time, to maintain 1/2 inch of the wire sticking out of the out of the gun. If you are welder thickness on the two edges of the irregularity gaps, you can have the arc back and forth from side to side as you travel, bringing the distance between the two edges. All right, let's go over the pictures. All right, 543. The tip of the work distance very important to maintain the short circuit of the wire when practicing watching the arc closely, and the white hot melting end of the wire should stay about the same short distance from the puddle wire speed. The welding travel speed control this. All right, your contact tip, your nozzle, the wire protrusion, 5/16 to 1932 of an inch, and the arc. 545. This is what some of the practice welds look like. The heat setting was too hot. It was too hot here. The welder wasn't very steady with the gun. Usually both hands with the fine comfortable position to hold the steady but not amount of spatter, making them breaking the arc. 545. This production weld is professional show of how clean the perfect MIG weld should look, and the heat affected area of either side of the small weld has good penetration there. Minimal spatter that he was eventually evenly placed on the both pieces of the tubing. All right, 546. Welding current effect for the penetration of the weld side of the beads. Ideally, we look for the good penetration without too tall, too wide a bead. Your bead width, your bead height, and penetration depth. 547. After you lift here, the fig MIG bead was too low, and amperage of the thickness of the material penetration show the bead stick up to high. A certain current amperage was used. The right at the amps were too high. The right hand bead. Bead may look okay if the penetration was too deep. The drop through the backside there was some undercutting on the other side either side of the bead. All right, 548. After you have practiced sufficiently, develop the natural rhythm of the torch movements to create a good bead and overlapping puddles. This shows the arc generation through 1 to 3, 2, 1, 2, 3, and the overlapping beads. Correct. Incorrect. So insufficient welding strength of pores or parallel could separate when it's finished with a grinder. Good penetration, easy to grind. Incorrect. There was good penetration, but finished grinding will be both difficult and time consuming. Alright, 549. The arc voltage, length, and shape of the bead profile of the penetration. Cut a few practice welds in half to examine the beads. The shape, overlapping puddles should have round, exposed, not sharp triangle edges. Alright, you have your wire, your arc length small, the arc low, very low, arc voltage low, arc voltage medium, arc length medium wire, your arc voltage high, arc length long. Alright, 550. The thickness for the panel that you're working on determines how far apart the initial tacks should be in line with your parts. On the thin materials, you're in a lot more tacks. Approximately 30 times the 3-panel thickness for the tack welding points. Correct. When working with large panels with limited thin materials, such as when doing body with welding the new quarter panel, warpage is a problem unless keeping the heat down with making lots of tack welds, switching back and forth to close coolest section to add the short weld. Move another section to switch back and forth until the whole seam is done. Continuous weld might be to put too much heat and warp the new panel, requiring lots of hammer work to straighten. Alright, right angles. Instead of the straight weld butt and panel with the thin metal area, often joined in special welds in the top of the handle and punch out with a small hole. Your MIG weld around the hole. Join the top of the panel to the bottom. 553. Door handle lock holes have been filled on the street rods using small circles and sheet metal thickness for the original metal in order to avoid warping. The circles were filled with the tacking, filler piece with a few places waiting for the part of the cool off, then adding a few more tacks until the whole circle was made in tacks. Alright, sometimes start and stop techniques works well with the bridge gapping of the filling of the hole. You watch the arc with the weave from one side to the other, then pause and go to the trigger for a second of the torch for the same spot, allowing the puddle to do solidifying the post. Pull the trigger again, make it building a new puddle, at least one to fill the hole. Just make the tack weld around the edge of the hole until you have made it smaller. Let the metal cool, then add an inner row of tacks inside of the first ring until you close up the hole in the filler metal. This is often done with the sheet metal holes in bodywork. But any hole larger than a dime should be filled with welding in a circle new metal with the same thickness. Alright, the beauty of the make process is the torch is one-hand operation, which allows the use of the other hand to stay your primary hand of the draw a smooth bead. Also, the torch same the distance of the weld at all times. Unlike all the welding rods, they are always getting shorter. MIG welding does not require stopping the changing electrodes either, so you can concentrate nicely on you're doing the welding or on one hand if the MIG welding temps attempt some of the welder operated the torch one hand while they actually hold something to work on their other hand. This okay for the tack welding. When you have the body panel, you need to align the whole alignment with the tack, but your better seams are made with it when you hold the torch with your both hands. Some of you forget lower brightness and spatter when the MIG process attempted to tack parts together without using a helmet. Body and men in particular are prone to hold the panels in alignment, put the torch in needs, and to be close with the eyes made to attack with weld. And second, although MIG welding does not produce intense light and spatter than arc welding, you are still subject to both radiation burns and some splatter. Do not even take a chance without eyesight. A blob or splatter on your bare eyelid could really be dangerous. A much better practice, and of those ones recommended. Would be used as some clamps and other devices. See Safety Shop in a chapter. 554. When welding a corner joint such as the T-section angle, the gun is about a 45-degree angle to aim equal heat and filler on both pieces. All right, 555. Don't be tempted to load the spatter on the MIG welding to just shut your eyes when tacking body panels. If you need speed and conveniency while tacking, use a handheld safety shield when lenses, as shown here. Welder has a long sleeve, but should also have gloves on, turn around hat to protect his hair from hot spatter. 556. The best argon flow meters professional use are the type of the floating ball inside of the glass tube. Every time they pull the trigger, the ball floats up on the scale and indicates the gas flow of the machine. A normal working distance for the machine, the welder can more easily read this as a dial gauge. It must easily be tasted to see a glance and forget to turn on the gas at all. Alright, to hold your panels in alignment, use the helmet. If you do not like both flipping a big helmet up and down just as much as a series of quick tacks, then use a handhold face shield with the lens, and it's very easy to hold the shield in your left hand while tacking with your right. It goes instantly from a shield to an unshielded view without view of work. Alright, if you're welding along and all of a sudden the bead goes bad, there are several things to consider. You have been steady with the arc distance and travel speed. Perhaps the draft temporarily blew the shield gassing away from the weld. This is not a rough draft. Look in the main torch cable. If there's any beads and kinks in their position which you hold in it when welding, the flow of gas can be restricted easily. Watching your gas battle gauge will while you pull the trigger for a second to see how the flow rate has changed. If the gas bottle is running low, the better equipped the MIG machine. As most shops have the regulator with the flow meter to indicate the flow rate. Illustration. It consists of the glass tube with a colored ball inside of the float with a during glass flow number line and floats to indicate the flow rate. Advantages of these most expensive regulator meter setup was whether the welder can see the glass flow, whether he is at work, and he doesn't have to go back to the machine to read the gauge dial. Alright, the illustration. When the MIG welding aluminum, especially thin aluminum wire itself, fairly example, which can cause feeding problems inside the machine because the drive rollers are pushing a soft wire along a long distance. This is a spool gun which holds a small roll of aluminum wire at a gun for easy feeding. Aluminum welding will be more challenging than steel, regardless of the welding method. Aluminum really soaks up the heat, and you have to use a thicker wire and more heat and wire gas flow to the weld. Equipping your machine to weld aluminum means setting up the gas flow almost twice as high as your steel, using aluminum wire, using right gas mixture, replacing the wire line in your torch with a Teflon liner, using a contact tip that is one wire size bigger than the aluminum wire. This is the reason for all this, is aluminum wire tends to grow more than heat than steel wire. The wire tension needs to be fairly light, and because of the bird nesting is most commonplace for the less stiff aluminum wire. In fact, there are special MIG guns made for production work with aluminum wire. They have spools wire on the right at the gun, called spool guns. Spool guns eliminate the wire feeding problem, trying to push the soft aluminum wire all the way through the cable to your torch. The illustration. The wire speed should be faster than the equivalent steel size wire, and forehand technique recommended because it pulls the preheated ahead of the puddle, and there are two extra steps. The welding aluminum metal must be kept scrupulously clean and preheated to 350 to get a good weld. You should keep 558. For 5 tight quarters, such as the muffler work, there other round tube situation. HTB makes a MIG gun flexible swan neck. It can even be used in straight head to reach into the spot where you cannot get your hands. 559. Muffler shops are finding that MIG machines faster and safer to operate under the car than traditional oxyutility and torch equipment. There's no constant relighting, adjusting the flame to worry about when initial tacking, welding various pipe sections together. 560. A handy welding cart for the MIG welding will probably be on one of the first home shop projects. This one simply built for the 1-inch angle iron, fitted with a steel bottom shelf to hold the welder, bolt, bottle, accessories, and top made with the front from a piece of the polished aluminum diamond plate purchased from the remnant plow scrapyard. Caster wheels that were adapted quickly and welded there, mounted to the bottom. Alright, 561. When you find many used for the welder, once you get used to this example, typical home project plywood covered rear bumper extension for a truck. This is used for the carrying extract camping gear, using a tailgate for working for the cooking of the camping. It is also a wide step for stepping out of the truck, the camper shell on the truck. Alright, 562. The camper step with a MIG welder from 1 inch to the steel tubing with a brace with a 2 by 2 inch tube that fits in the truck's itch, fit, and lift the receiver. 563. Street hot rod shops customize the restoration shop using MIG welder become more and more for its convenience ability to handle the delicate material. 1932 Ford door has a new skin MIG welder along the bottom of where the original door was rotted. 564. The door bottom was welded with only a series of very short welds alternating with one area to another, keeping and putting in the meat much heat in one time and into an area. Eventually, the whole seam to weld. The LTC Easy Grinder Deoxide MIG wire is perfect for these kind of jobs because it grinds easy and without introducing too much paint, heating, preparing the seam for the finishing of the paint. 565. Customers restore and found the achieving the perfect gap around the panels in first-class vehicles often involved with the grinding material off the edge of the adhered, adding silver or metal to add along the door edge to the right to close up the gap. Welding these thin strips at perfect providence of small MIG machines. A stainless steel wire brush handily and strictly used in cleaning of aluminum. Do not use the brushing steel or will later contaminate your next aluminum weld. Short welding aluminum with a torch further out than the wood steel with say 1 inch. Always start an aluminum weld with the end of the wire cut off that is fresh. With snappers, as soon as your arc stops, move the torch closer and move down 3/8 of an inch to 1 inch work from the work. Instead of the torch angle, we would recommend if the steel hold the gun almost square with the material inclined 5 to 15 degrees in the different direction of the travel. The puddling will seem to be most different than the aluminum and the steel. The puddle frees with the fiery path. The only change that you notice for the molten area in the area of the place that is shiny. Aluminum has a narrow gauge of melting before it vaporizes. They are highly susceptible to tiny amount of the foreign material. If you see the back speck appearing as you go along the seam, there represents the impurities coming to the surface. Short circuit type MIG machines have been discussion and better with aluminum being welded is relatively thin. Thick parts are better welded with TIG equipment and spray arc pattern found in the larger industrial MIG machines. There will be a little bit more maintenance of the nozzle contact tube with the welding aluminum due to the increased spatter. The use of the anti-spray spatter spray inside the nozzle, dipping it in a hot gun tip to nozzle. Get it when producing any less than gunk inside the gun, and make it and remove the smoke much easier. It does it with seal welding as you use any anti-spatter chemical. It can act as a contaminant to the aluminum weld. So applying this anti-spatter before you use the torch on any piece of scrap aluminum to burn it into the chemical so it won't drip onto your good weld. Alright, one of the most common aluminum welding jobs in automotive work, repairing cracks in cylinder heads, the bell housing, other large aluminum casting. Cracks should be welded, grounded, or out of the virgin metal, bead before welding. These parts can be really soak up the heat, and so they should be thoroughly preheated, either in an oven or oil oxyacetylene torch fitted with a rosebud tip. The old-timers' method of measuring the preheat was by coating the part with a black suit for overly rich gas torch, then was torching it set properly with the part where it was heated until the suit burned off. There was the good considering enough preheat. Obviously, too much preheat could require complete remachining of the part of the welding to correct warpage. Modern welders use the temperature marking sticks to get the exact preheat. Maintenance of the MIG equipment are simple but should be performed regularly to keep everything operating smoothly. The most often maintained items of the gun components and contact tubes wear out with the frequently used welding, well as becoming burned, such as when your hose kinks to the gas stops during the weld. Sometimes the hot wire welds itself into the contact tip. Often the problem can be fixed by the filling of the end of the tip of to the free of the wires bond. On pushing the wire side of the cutting of the pliers, it cannot if it not can be removed the nozzle. Unscrew the contact tip, cut off the wire, the feed through the wire with the new contact tip, to screw the tip of it in place, replace the nozzle. Use an anti-spatter agent often to clean the out of the nozzle. Keep it at the tip before the start of the project, during the project, after the project. When you replace the roll of the wire, use a blowgun or your air compressor hose to blow any of the dust out of the inside cabinet. Blow off the roll of wire before you install it. Keep the driver rolls clean within mineral spirits and lint-free cloth. Often professional welders will tape pieces of lint-free cloth inside the MIG welder, inside their MIG welder, such that it drags across the wire so as it comes off the roll. The cloth helps snatch any lint or dirt from the wire before it can collect in the cable or torch. That's about all there is to MIG maintenance. The welding system that has really become the prominent method of home shop the user is last decade. If you have read all the above, you can see what is many of the advantages. When you started using, really appreciate the lack of the paraphernalia. I guess that paraphernalia. And each starting and maintaining arc and cleaning the cleanliness of the weld, reducing shop the fire hazard, our ability to wide various materials, including the thin sheet metal, having combined with the take of the MIG process out of the express for the hands of the production welders, and give the hobbyists, artists, and farmers and restoration techniques a very practical, easy to learn welding system. Alright, this shows your welding defects and defect condition, pores and pits. It shows the pits and pores. Your main cause is there's rust or dirt on the base metal. The rust is moisture adhering to the wire. Improper shield action. The nozzle is blocked or the line of the gas flow and the volume is low, or weld is cooling off too fast or the arc length is too long. Undercut. The arc length is too long, the gun angle is improper, and the weld speed is too fast. Your overlap. The weld speed is too slow, and the arc length is too short. Your insufficient penetration. Welding current is too low, arc length is too long, and the end of the wire is not aligned with the butted portion of the panels. Excess welded spatter. Arc length is too long, rust on the base metal, and gun angle is too severe. Bead not for uniform. The contact tip is worn and deformed. The wire is oscillating as it comes out of the tip, and the gun is not steady during welding. Burn through. Welding current is too high. The gap between the metal is too wide. The speed of the gun is too slow, and the gun's base metal distance is too short. Alright, Chapter 6, TIG Welding.